Dear students, today I am presenting a new video that is related to quantitative aptitude. The chapter is number system. In this quantitative aptitude, number system is very important. This video dedicated to all the aspirants who are preparing for IAS, CSAT, paper 2 of PT, banks, SSC, MBA, CAT and other competitive examination. I think it will be very useful for you. This video, please take seriously this video. Let's start this video. Number system. What is number system? A number system in which we study different types of numbers, their relationship and rules in them is called number system. In Hindu Arabic system, we use the symbols 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In this Hindu Arabic system, we use these symbols. These symbols are called digits. Out of these 10 digits, these are 10 digits. 0 is called insignificant digit, whereas others are called significant digits. Now comes to numerals. Now what is numerals? A mathematical symbols representing a number in a systematic number is called a numeral, represented by a set of digits. All the digits 1, 2, 3, 4. Now the problem is how to write this number. We put digits from right to left at the places designated as units, tens, thousands, hundred thousands, 10,000s, lakhs, 10 lakhs, crore and 10 crore arab. So here is example. You can take help from this example to understand this, how we can write a number. For example, take this number, all the 4 numbers. I have presented this in table. Now we start from first numbers. First number digit in 3 units at the place of units. 10, 2, tens, unit tens, 100 at 100 place 7, 0 at 10,000, 8,000 and 6, 10,000. At lakh place 1, 1. 10 lakh place 10 lakh. Crore 9 crore. 8, 10 crore. And 5 arab. It means 5 arab, 10 crore, 89 crore, 5 arab, 89 crore, 41 lakh, 60,723. This way we can call these digits. Similarly, the second number, the same, and third one and last this number. We can represent in tabular form. You can consider easily, very well from this table. I hope you have understood this table, how we write the numbers from left to right. Right to left from 3 to 7, 0, 6, 1, 4, 9, 8, 5. Now we move to face value. What is face value? of digit in number. In mathematics, face value is the actual value of the digit in a number. In numeral, the face value of a digit is the face value of digit itself, irrespective of its place in the numeral. For example, take this example 8925. The face value of 9 is only 9. The face value of 2 is 2. The face value of 8 is 8, and so on. Now move to place value, local, also called local value. What is place value? In numeral, the place value of a digit changes according to the changes its place. Place value is the basis of our entire number system. This is a system in which position of a digit in a number determines its place value. The number is, for example, number is 42,316 is different from this number 61,432 because the digits are in a different position. Each digit has a value depending on its place, the place value of the digit. Let us consider an example. What is the place value of 6 is 64. Place value of digit is equal to face value of the digit into face value of the place. 6 in 10 place. 4 is at unit place, 6 is in 10 place. So 6 in the 10 place, hence the place value of 6 is in 64 is 6 into 10 is 60. Now here is the example. Find place value of the digit 83954,127. So 8 is at a place of crore, 8 crore. Place value of 8 is 8 into how many 0? 70. 8 into 1 into 70. 8 crore. 10 lakhs. 3 place value of 3 is 3 into 10 to power 6. 3 lakh. 30 lakh. At a place of 9. Place value of 9 is 9 into 10 to power 5. That is 99 lakhs. Now the 10,005. Place value of 5 is equal to 5 into 10 to power 4 is equal to 50,000. Similarly, the thousands at 4. Place value of 4 is equal to 4 into 1000 to 4000. Hundreds. 100 place value of 1 is equal to 1 into 100 is equal to 100. Similarly, the tens 2. Place value of 2 is equal to 10 into 10 is equal to 20. Unit place of 7 place value 7 into 1. I hope you have successfully understand this place value. Now come to number line. What is number line? Number line is a line that starts from 0 and goes towards positive infinity when it moves to right and towards negative infinity when it moves to left. Consider this is the straight line, that is number line. Line, a simply line at which place we have placing some bars, horizontal bars, starting from 0 moving towards left side. This will be negative, -1, -2, -3, -4, -5. Similarly, towards positive from left to right side, +1, +2, +3, +4, +5. This is towards negative, towards positive. The difference between the value of any points on the number line also gives the distance between points. For example, on this number line, the point +3 and point -2, the difference will be 3 minus -2 is equal to 3 plus 2 is equal to 5. Types of numbers. First is natural number. What is natural numbers? Natural numbers are counting numbers. The example, n is equal to 1, 2, 3, 4, 5 to infinite. All natural numbers are positive. Therefore, infinite natural numbers. But 0 is not a natural number. 0 is not a natural number. You must mind it. Therefore, 1 is the smallest natural number. 1 is smallest number 1, and the -2, -31, 2.56, 0 are not natural number. Please listen and understand, try to understand carefully, because the number system is very important for quantitative aptitude, because for all arithmetics dependent on numbers. Let us now know the properties of numbers. First, successor. The next natural number just after any natural number is n is called its successor, that is n plus 1. N is equal to n plus 1, the successor. The successor, for example, the successor of 3 is 4, successor of 7 is 8, etc. Second property is closure law. For any two natural numbers a and b, a plus b belongs to natural number, a into b belongs to a natural numbers. For example, 4 plus 4 is equal to 7, that is belongs to natural number. Natural what is natural? 1, 2, 3, 4, 5 to infinite. Similarly, 3 into 4 is equal to 12, it is also comes into natural number. 4 plus 5 is equal to 9, this is also in natural number. 4 into 5 is equal to 20, this is also into natural number. Third property is commutative law. For any natural number a and b, a plus b is equal to b plus a, and a into b, b is equal to b into a. For example, 5 plus 6 is equal to 6 plus 5 is equal to 11. We will only interchange the place of digit. Similarly, 6 plus 7 is equal to 3. We are also write in 7 plus 6 is equal to 13. 5 into 6, 30. 6 into 5, interchanging the digit 5 and 6, their place, changing their place, that is 6 into 5. Similar the result 30. 6 similar 6 into 7, we are also write 7 to 6, the result is 42. The next property is associative law. For any three natural numbers a plus b plus c, similar a plus b bracket b plus c bracket close. Similarly, a into b into c, similarly a is equal to bracket b into c bracket close. In digit form, let us take example 8 plus 9 in under bracket plus 10. This is similar, it is 27. If changing its place of digits, 8 plus under bracket 9 plus 1 is similar 27. Similarly, 8 into 9 under bracket into 10, it will be similar result 720. 8 into under bracket 9 into 10 is similar 720. This is called associative law. Now, next property is multiplicative identity. One is the multiplicative identity of every natural number, as 3 into 1 is equal to 3, 4 is into 1 4, 11 into 1 11, 18 into 1 18. Next property is cancellation law. For any three natural numbers a, b, c, a plus b is equal to c plus b. Here b and b here common, so it will cancel out. The result is a is equal to c. Similar in multiplication, a into b is equal to c into b. Here b is common both sides, so it will be cancelled out. The result is a plus c. Next property is distributive law. For any three natural numbers a, b, c, a into b under bracket b plus c. If we after opening the bracket a into b plus a into c, but a plus b into c, this is not equal to a plus b into a into c. Mind it. For example, 4 into under bracket 5 plus 6 is equal to, after opening bracket 4 into 5 plus 4 into 6 is equal to 44. Both LHS and RHS is equal to 44. These are the property of natural number. Next come to whole number. What is whole number? Whole number, all natural numbers are 0, form the set of whole numbers. In natural number, 0 is included then it is the set of whole number. 0 is an even number. Mind it, 0 is an even number. 0 is the smallest whole number. Natural number, in natural number 0 is not present, but in whole number 0 is present. 0 is the smallest whole number. Mind it. Whole numbers are called as non-negative integers. Now come to third number, integers. Whole numbers and negative numbers form the set of integers. Here is whole number and negative numbers. Both are coming under integers. For example, -3, -4, -2, -1, 0, 1, 2, 3, 4. Both side from 0, left to and right, adding up, considering it, that is called integers. Types of integers. Positive integers, natural numbers are called as positive integers. 1, 2, 3, 4, these are called positive integers. Negative integers, negative of natural numbers are called negative integers. For example, -1, -2, -3, -4. 0 is neither positive nor negative integers. Mind it. Then non-negative integers, the set of integers 1, 2, 3, 4. This is called non-negative integers. And non-positive integers, the set of integers 0, -1, -2, -3, infinite is called as non-positive integers. We can represent the integers on a number line. The same we have told you about this number line. Similarly, 0 the middle, towards left to right positive, 1, 2, 3, 4 infinite, and from right to left, from 0 towards the -1, 1, 2, 3, this is negative. Now all integers, whole numbers, natural numbers, etc. can be shown on this number line, where every integer is represented by some points on the line. It can be said that there is no any longest or smallest integers. Every integer has a predecessor or a successor. An integer is smaller than those integers which are on the left side of it on the number line. It means -4 is greater than -5. 3 is greater than 1. 10 greater than -4. You can see on number line here. -4 is greater than -5. -3 is greater than -4. -2 is greater than -3. -1 is greater than -2. 0 is greater than -1. Similarly, 1 is greater than 0. 2 is greater than 1. 3 greater than 2. 4 greater than 2. 5 is greater than 4. Similarly, -6 is smaller than 0. It means 0 is greater than -6. 1 is greater than -2, etc., etc. For example, arrange the following integers in ascending order: -4, -8, 9, 0, 4, 18, -24. With ascending order, what is the smallest number and what is the greatest number? Here is -24 is the smallest number and 18 is the greatest number. In ascending order: -24, -8, -4, 0, 4, 6, 9, 18. Similarly, another example, arrange the following integers in the descending order: -18, 19, 16, 33, 82, -6, 88. What is the greatest number? Here in this example, 88, and the smallest -18. In the descending order: 88, 82, 83, 19, 16, -6, -18. The properties of integers. Closure law is followed by all integers. Quantitative law and associative law is not followed by all integers for subtraction. Here is quantitative law and associative law is not followed by all integers for subtraction. In subtraction, quantitative law and associative law is not followed. As I mentioned in previously, what are closure law, what are quantitative law and associative law, you must see again. Here is, for example, minus 6 is not equal to 2, 6 minus 4. Here is minus 2 is not equal to 2, is equal to 2. Similarly, 4 minus 6 minus 2 is not equal to 4 minus 6 minus 2. Here is minus 2 minus 4. Here 4 is a 0. But it is valid for addition and multiplying, as 4 plus 6 is equal to 6 plus 4. Here is minus 3 plus minus 2 is equal to minus 3 minus 3. These are valid for addition and multiplying examples. 4 plus 6 is equal to 10. We are changing the place of 4 and 6. 6 plus 4 is equal to also 10. Similarly, in this example, minus 5 is equal to minus 5. Similarly, in multiplying, 4 into 6 is equal to 6 into 4 is 24. Similarly, minus 3 into minus 2, 6. Similarly, minus 2 into minus 3 is equal to 6. And this is also valid. You can check it. It is for you. You check it. Additive identity of all the integers is 0. Multiplicative identity of all the integers is 1. Minus 3 plus 0 is equal to minus 3. 8 plus 0 is equal to 8. Minus 5 into 1 is equal to minus 5. 7 is equal to 1 is equal to 7. Additive inverse of integer is age minus a. The additive inverse of 7, 8, 9, 15, minus 3, minus 5, minus 6 are, what is inverse of this? Minus 7, minus 8, minus 9, minus 15 and minus 3 to 3, 5, 6 respectively. Distributive law and multiplication over addition or subtraction. A into B under bracket B plus C plus minus C. Here is A into B plus minus A into C. This is valid. For example, you can check it by this example. 4 into under bracket 5 plus minus 7 is equal to 4 into 5 plus minus 4 into 7. Division by 0 is not defined in mathematics. There is no any definition, cannot be defined if there is division by 0. Division by 1 is actually unification, not division, so it is an improper division. Next is decimal number. What is decimal number? These are numbers which have a decimal value attached to them. Thus, What is decimal number? These are numbers which have a decimal value attached to them. Thus 1.3, 14.76 minus 12.24 are all decimal numbers since they have certain values after the decimal point. Thus concept of decimal is closely related to the concept of division and divisibility. Divisor 2 gives rise to decimal point 5. Divisor 3 gives rise to decimal point 333. It means 1 by 2 is equal to 0.5. Similarly, 1 by 3 is equal to 0.333. Now comes to even number. What is even number? A counting number which is divisible by 2 is called an even number. For example, 2, 4, 6, 8, 10, 12, etc. The unit place of every even number will be 0, 2, 4, 6, 8. Every number having a unit place will be 0, 2, 4, 6, 8. Odd number. A counting number which is not divisible by 2 is known as an odd number. That is 1, 2, 3, 5, 7, 9, 11, 13, 15, 17, etc. The unit place of every odd number will be 1, 3, 5, 7 or 9. Here is even plus even is equal to even. For example, 2 plus 2, 4. Even minus even is equal to even. 4 minus 2 is equal to 2. Even is equal to even is equal to even. 2 into 2 is equal to 4. Even divided by even it may be even or odd. 4 by 2 is equal to 2. 6 by 2 is equal to 3. Even plus odd is equal to even. For example, 3 plus 3 is equal to 7. Odd minus odd is equal to even. 6 minus 3 is equal to 3. Odd into this will be 7. This is 4. Odd minus odd, 7 minus 3 is equal to 4. Odd into odd is equal to odd. 3 into 3 is equal to 9. That is also odd. Odd divided by odd. 15 by 3 is equal to 5. 9 divided by 3 is equal to 3. 7 by 3 not divisible. So you know this is working, but I am carry on. Here even plus odd is equal to odd. 2 plus 3 is equal to 5. Even minus odd is equal to odd. Why not this is erasing? Now we comes to even plus odd is equal to odd. 2 plus 3 is equal to 5. Even minus odd is equal to odd. 6 minus 3 is equal to 3. Even is equal to even into odd is equal to even. 6 into 3 is equal to 18. Even by odd is equal to even. 18 by 3 is equal to 6. Odd plus even is equal to odd. 3 plus 2 plus 5. Even minus odd. Odd minus even is odd. 5 minus 2 is equal to 3. Odd into even is equal to even. 5 into 2 is equal to 10. Odd by even never divisible, like 5 by 2 is equal to 2.5. Odd to power odd by even, that will be odd. For example, 3 to power 6 by 2, that is 3 to power 3 is equal to 27, that is odd. Next is prime number. A counting number is called a prime number when it is exactly divisible by 1 and itself. For example, 2, 3, 5, 7, 11, 31. That is when it is exactly divisible by 1. Unity is the representative of the number 1. 2 is the only even number in which prime number. 2 is only even number. 2 is the only even number which is prime. A prime number is always greater than 1. 1 is not here. 1 is not prime number. Therefore, lowest odd prime number is 3. Every prime number greater than 3 can be represented by 6 n plus 1 when n is integer. There are total 25 prime numbers up to 100. There are 46 prime numbers up to 200. 2 is the only prime number and the least prime number. 2 is only even prime number and the least prime number. 1 is neither prime nor composite number. There are infinite prime numbers. A list of all the prime numbers up to 100 is given below. 2, 3, 5, 7, 11, 13, 14, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Similarly, prime numbers between 100 to 200 is given. You can check it. It is only divisible by 1. The remainder when prime number p is greater is equal to 5 is divided by 6 is 1 or 5. However, if a number on being divided by 6 gives a remainder of 1 and 5, the number need not be prime. For example, 7 divided by 6 is equal to 1 to 1 by 6. Similarly, 11 divided by 6 is equal to 1 by 5 by 6. Here is 1 remainder, here is 5 remainder. 7 and 11 are prime numbers. Here is 25 divided by 6 is equal to 4, 1 by 6. 35 divided by 6 is 5 by 6. Here is also remainder 1 and 5, but 25 and 35 are not prime number. The remainder of division of a square of the prime number greater than or equal to 5 divided by 24 is 1. For example, 73 by 24 is equal to 3, 1 by 24. The remainder is 1. If a and b are any two numbers or two odd numbers, then a square minus b square is composite. Here is also a square plus b square also composite. Now the problem is how we can check whether given number is prime or not. For example, p is the given number, then find whole number x such that x is greater than square root of p. Take all the prime numbers less than or equal to x. If none of these divides p exactly, then p is the prime number, otherwise p is not prime. For example, let us p is equal to 193. Similarly, square root 193 is less than 14. Is 14 196. Square root of 196 is equal to 14. But here is square root of 193 is lesser than square root of 14. So 14 is greater than square root of 193. Prime numbers up to 14 are 2, 3, 5, 7, 11 and 13. No one of these divides 193 exactly. If this number divides 193, it will be non-prime. Here is up to prime numbers are 1, 2, 3, 5, 7, 11, 13. 193 square root 193 is not divisible by these numbers. So this is a prime number. 193 is a prime number. Let us take another example. 241 is a prime number, whether it is prime number or not. The square root of 241 is equal to 15. Consider 16. 225 is the square root of 225 is equal to 15, and 16. 256 of the square root of 256 is 16. Now divide 241 by all the prime numbers below 16. 2, 3, 5, 7, 11, 13. Since 241 is not divisible by any one of the prime numbers below 16, so it is a prime number. Composite numbers. Next is composite number. Composite numbers are non-prime natural numbers. They must have at least one factor apart from 1 and itself. A number other than 1 which is not a prime number is called composite number. It means it is divisible by itself. What is composite number? Composite numbers are both be odd and even number. These are not non-prime natural numbers. They have must one factor apart from 1 and itself. That there is example 4, 6, 8, 9. It is divisible by 1, also 2 and 4. Here is 6. It is also divisible 1, 2, 3, 6. 1 is neither prime number nor composite number. Every natural number except 1 is either prime or composite. Trigonometry law. If there are any two natural numbers a and b, then there exists one and only one relation necessarily. Is a greater than b, second a is equal to b, or third a is less than b. This is called trigonometry law. Next is co-prime number. What is co-prime number? Two natural numbers are said to be co-prime if their ACF is 1. Highest common factor I will teach you in coming video. For example 7, 9, 15 and 16. If they have no common factor other than 1, it is not necessary that numbers involved in the pair of co-primes will be prime. Even they can be composite numbers as seen in the example. Co-prime numbers may not be prime. Next is constitutive numbers. A series of numbers in which the next number is 1 more than the previous number, or the predecessor number is 1 less than the successor, or just they can be divided by 1. For example 10, next 11, 12 these are consecutive numbers. These are increasing 1 by 1. 10 plus 1, that is 11. 11 plus 1, 12. Similarly 7, 18, 19, 20, 21. Similarly 7, 17, 7, 18, 7, 19, 7, 20, 70, 21. These are consecutive number. Perfect number. What is perfect number? When the sum of all factors including 1 but excluding the numbers itself of the given number is the same number of, then the number is called perfect number. 628, 496, 68128 etc. So far only 27 perfect numbers are known. All the factors of 28 are, if we factorize 28, number 28, we will find 1, 2, 4, 7, 14, 28. These are factors of 28. Adding of these factors excluding 28, 1, 2, 4, 7 and 4, we find 28. Hence 28 is a perfect number. Now we come to what is triangular number. The triangular number is obtained by adding the previous number to the 9th position in the sequence of triangular numbers, where the first triangular number is 12. The sequence of triangular number is given below: 1, 3, 6, 10, 15, 21, 28, etc. These are triangular numbers. What is rational number? A rational number is defined as a number of the form a by b, where a and b are integers and b is not equal to 0. For example 3 by 5, 7 by 9, 8 by 9, 13 by 15 etc. The set of rational numbers encloses the set of integers and fractions. The rules given above are addition, subtraction, multiplication, division also apply on the rational numbers. These are all the rules of addition, subtraction, multiplication and division are applying on rational numbers. What is rational number? This is a set of integers and fractions. These are fractions. Irrational number, the number that can be not be expressed in the form of p by q are called irrational numbers. So p or q are integers and q not equal to 0. Fractions that are not terminating, non-periodic fraction or are irrational numbers. For example, square root of 2, square root of 3. These are non-terminating. It is going on. For example, square root of 3, it will be 3 square root of 2 is equal to 1 by 4 1 4 1 4 1. Similarly repeated. What is real number? Real numbers include irrational and irrational numbers both. All numbers that can be represented on the number line are called real numbers. Every real numbers can be approximately replaced with a terminating decimal operation, and addition and subtraction, multiplication and division are valid for both whole number and real numbers. The example of real numbers are 7 by 9, 8 by 9, root 2, square root of 5, pi, etc. Real numbers including rational and irrational both. All numbers then can be expressed on the number line. All numbers that can be represented on the number line are called real numbers. Every real numbers will follow with a terminating decimal operation for addition, subtraction or multiplication, division are valid for both whole numbers and real numbers. I think this video is become too long. Now I think you have grasped all this number system. Comment in my comment box how you like this, and also comment what type of video you liked from me. Please subscribe my channel, like and share my video, and press bell button so that my video comes to you earlier. Thanks for watching.